Welcome! In this session we will talk about integrating PoolParty with RDF triple stores. We will start by briefly talking about graph databases and RDF triple stores. We will then explore some use cases where it makes sense to extend PoolParty with an additional triple store. Finally, we will take a look at an example integration of PoolParty with a triple store. Graph databases are a category of data storage systems. As the name suggests, the defining characteristic is the fact that they store data in graph format. What all graph formats have in common is that data is modeled to consist of data points and defined relations between those data points, i.e., nodes and edges. This way of storing data is thought to be similar to the way in which humans think and speak. The basic structure of a sentence consists of a subject, a predicate, and an object. The predicate is equivalent to the edge in the graph, which connects the data points of the subject and the object. Graph databases store data in a very similar way. There are many different implementations of graph databases, and some of them are unique in the way they store information. Many graph databases offer specialized features, such as weight edges or hypergraphs. In order to be able to use these features, some graph databases have their very own query language that allows to access data that is stored in these complex data models. Specialized features and custom query languages have the disadvantage of making the integration of such graph databases with other systems difficult. Every graph database would need to be integrated with each other system on a one-on-one basis. This is where RDF triple stores come in. In contrast to many other graph databases, RDF triple stores are based on a standardized data model, the RDF data model standard published by the World Wide Web Consortium. Following these standards, all data managed in RDF triple stores is compatible with other software that also follows these standards, such as PoolParty, for example. RDF triple stores also come with a standard query engine. The Sparkle standard, which is also published by the World Wide Web Consortium, defines a standard query language for RDF data, which is implemented in the Sparkle query engine of every RDF triple store. Another feature that makes RDF triple stores popular is the fact that many of them can support reasoning over data. Reasoning describes a set of methods that allow to infer facts about data from other data. RDF triple stores are defined by the use of the RDF data model. The underlying technology can vary, though. It is possible to use a graph database to store RDF triples. But it is also possible to use a relational database or a NoSQL database for storing RDF triples. As soon as a data storage system is capable of both storing data in RDF format and processing Sparkle queries to access this data, it can be called an RDF triple store. What all graph databases, including triple stores, have in common is the flexibility of the data model. The data schema can be extended or modified without the need to change any defining structures, in contrast to tables in relational databases. In this way, the data model allows to express complex information without much technical effort. PoolParty also uses an RDF triple store as internal data store, Eclipse RDF4J, formerly known as Sesame. Even though PoolParty comes with this internal triple store, there are many cases in which it makes sense to connect an additional external triple store with PoolParty. At the moment, PoolParty can be set up to use either one of the following triple stores as an additional store out of the box: Virtuoso, Stardock, GraphDB, RDF4J, and MarkLogic. The most common use case is that I want to build an application that uses data that comes from PoolParty in combination with data that comes from a different source. It is not feasible to keep all this data in PoolParty. After all, PoolParty is a semantic technology platform and neither a database nor a content management system. So we need an external triple store to keep the data. In some cases, it also can make sense to extend PoolParty with an additional triple store for reasons of performance. There are external triple stores in which it is possible to perform certain operations, such as the management of large text corpora, more efficiently than in the PoolParty internal RDF4J store. A third use case could be one where you would like to use specific functionality available in an external triple store that complements the functionality available in PoolParty. For example, you could use the configurable reasoning feature available in GraphDB to enrich your PoolParty taxonomy with inferred triples produced in the GraphDB store. Or you could export your taxonomy to a MarkLogic triple store and use xQuery to query your taxonomy jointly with XML documents, which is possible within MarkLogic. Or you can use Dardog's property graph feature for reification. Each triple store might offer specific functionality that could be advantageous to be used in combination with PoolParty data for specific use cases. Let's go back to the first and most common use case of wanting to use data that comes from PoolParty in combination with data that comes from a different source. This can come in many flavors. The most simple case would be that I have a thesaurus in PoolParty that would like to be able to query jointly with other information which I already have available in RDF format. As an example, we could think of an application that uses a PoolParty taxonomy which is linked to DBpedia. If this other RDF information is already stored somewhere where I can access it, it is not always necessary to set up an external triple store. Sometimes it is possible to run federated queries over PoolParty and the other store. For our example, I could run federated queries against PoolParty and DBpedia jointly. Depending on the complexity of these queries, it can happen that we quickly run into performance issues with federated queries. Sometimes it suffices to make the queries more efficient. But sometimes it is worth the effort to store the information I want to be querying jointly in one triple store. I can set up an external triple store in which I copy my taxonomy as well as that part of the DBpedia graph that I need for my application. Then I can run much more performant queries across both datasets. For our example, query performance might be the first argument for storing all the data in one triple store, but there are also other advantages. Especially with public linked data sources such as DBpedia, it can happen that their Sparkle endpoints are not always available. It is outside of your infrastructure and you are not able to control uptime and downtime. It therefore is often advantageous to keep synchronized copies of these datasets in your infrastructure to ensure availability. It can also be advantageous for the data you produce or maintain within PoolParty. By exporting the taxonomies to an external triple store, which exposes it to the productive application, you introduce a clear distinction between your development environment and your productive environment. In PoolParty, you can work on your taxonomies, extend and change them without interfering with the productive application. You can control the versions of your taxonomy that you would like to export to the external store, to be used for the productive application. A similar but more complex use case is the case where I have data coming from PoolParty in RDF format and data from other sources that is in a different format. This would be a classic data integration use case. Here, there are some steps needed in between to either convert the data completely to RDF, which is rarely necessary, or to create an RDF metadata layer that references to the content stored in different formats in different data storage systems. This is the more common setup. Refer to the session about advanced integrations of PoolParty with diverse data storage systems in this module to learn more about how such a setup could look like. Once we have a triple store in place in which I have integrated data from different sources, we can start thinking about what kind of applications we could build on top of this. Probably the most common application is a semantic search application. This is an application that allows to search and explore information, much like any other search application. It becomes interesting as soon as we add features that take advantage of the particular characteristics of semantic data. To name a few possible features, we could think of hierarchical search facets, info boxes which provide context information based on your current search or result set, visualizations that are calculated on the fly to give an overview over the data you are exploring, similar content search options that use graph similarity, and other features that support content discovery and guided search. Another common category of applications that can be built on top of a triple store are recommender systems. Recommender systems are a general category of applications that are concerned with providing a user with a recommendation of a product or a piece of information. These recommendations can be based on some search filters the user actively sets, or they can be personalized so that they recommend certain items based on characteristics of the user that the system learns in some way. In the end, recommender systems are a special case of a semantic search application. They are a semantic search application for defined configuration constellations. The main difference between a recommender system and any other semantic search application is that the objects that are being searched in a recommender system typically have less features that exist in clearly defined configurations. There are a number of other possible applications that could be built on top of such an architecture that combines PoolParty with an external triple store, specific for a range of different use cases. In this session, we can only cover the most common use cases and applications, but I would like to invite you to think beyond of what we covered here and consider how PoolParty, extended with an additional RDF triple store, could benefit your organization and your use case. Let's take a look at an example integration of PoolParty with a Stardock triple store. There are three components to this integration that we will take a look at: PoolParty, the Stardock triple store, and a semantic search application. Let's start with PoolParty. With those triple stores where there exists an integration with PoolParty, setting it up is simply a matter of installing PoolParty and the triple store and configuring the PoolParty server so that it can access the triple store. And then we can use a number of features that use PoolParty and the triple store jointly. One of those features is direct export of taxonomy data to the triple store. I can do this via the graphical user interface by going to Project, Export, RDF Project Export, and then selecting the action Export to Stardock. I can then select the graphs that I want to be exporting, click on Export, and PoolParty will actually store all my taxonomy data in the remote triple store. PoolParty will create a new graph in the triple store that uses the project space URI as the graph URI. The export can also be triggered by an API call. There is also another API call that uses PoolParty and the remote store jointly, namely the PoolParty extractor annotate and store call. With this call you can send files or text to the PoolParty extractor, who will do an entity extraction and store the results directly in the remote store. As soon as we have either exported data to the remote store or done an annotate and store call, this data is available in the remote store where we can query it or where it can be used by an application. This is the query interface of the Stardock triple store. How this query interface looks like and which functionality is available will vary depending on which triple store you use. I can now do a simple query that lists all the graphs available in that remote store. I will execute it, and then I will get a result set, a list of all the graphs that are in my Stardock triple store. I can see that I have a number of corpus graphs. You will remember that earlier we mentioned that the corpus management feature can be improved in terms of performance when using an external triple store. We also have a graph search graph, which is one that can be used by a graph search semantic search application. Here we also have a taxonomy graph that comes from a different project that has been exported to the Stardog Triple Store previously. And here at the very bottom we have our taxonomy, which we just exported from our PoolParty. Now let's take a look at the semantic search application that then uses this data. This search interface is based on the standard graph search application that is part of the PoolParty semantic integrator. It can be extended and adapted to suit your use case. At the left-hand side we have search facets. We can expand and collapse them, we can sort them alphabetically or by the number of documents that have been annotated by each of these concepts. My search facets actually correspond to top concepts in my SCOS taxonomy. So if we go back to our taxonomy, we will see that these boxes, division, location, company, actually correspond to my top concepts here, where I also have division, location and company, and that the narrowers of these concepts, the applied research, basic research and so on, actually correspond to the facets. I can trigger a search by simply clicking on one of the facets, and we can see that the nice visualizations in the center of the search application update with every search that I do. These visualizations are based on Sparkle queries that calculate the counts, in this case of documents, on the fly, so that they always reflect the current result set of your search. There are a number of other visualizations available, which also update with every search that I trigger. I also have a date range filter where I can select a date range from a selection box. I can also remove facets and then make them appear again. The selection of facets, so which facet should be actually displayed by default, should be chosen to help users in the exploration of data without overwhelming them with a choice of too many facets. At the very top we also have a full text search, which comes with a faceted autocomplete. So if I search for Austria, I can see that in my taxonomy I have Austria as a country, but I also have two different journals that have Austria somewhere in the title. Down here now I have my result set. I have the title, I have a short description, and with a more like this button I get additional results of similar documents. We also have a go to top button, and this is the set of features available in this example of a semantic search application. It is possible to add a number of additional features or to modify features to suit other use cases. Let's recap what we have heard in this session. We have talked about RDF triple stores and graph databases. We heard that graph databases are a category of data storage technologies that use graph data structures. There are different kinds of graph databases that come with different feature sets. RDF triple stores are one type of graph database that is standards-based. All RDF triple stores support the standard RDF data model, Sparkle as a standard query language, and many support reasoning based on RDF data. There are different implementations of RDF triple stores. PoolParty currently can work out of the box with Virtuoso, Stardog, GraphDB, RDF4J and MarkLogic. We also talked about use cases where it makes sense to extend PoolParty with an external triple store. First, we talked about use cases that require accessing data that comes from PoolParty together with data that comes from a different source. These data integration use cases can range from simply integrating two different RDF data sources to more complex integrations of data in different formats coming from a variety of storage systems. As a second use case, We talked about performance improvements that can be achieved by using an external triple store to support PoolParty in the processing of large text corpora. This can speed up the corpus management feature in PoolParty. A third category of use cases is characterized by the utilization of specific features of individual triple stores. We also talked about applications that can be built on top of a PoolParty plus triple store architecture, semantic search applications and recommender systems. It is possible to build a wide range of other applications on top of such an infrastructure, depending on the specific requirements of your use case. We then took a look at an example integration. We talked about PoolParty features that use external triple stores, corpus management, export to remote store, and the annotate and store API call. We took a look at a Stardock remote store and a semantic search application.